Welcome to the lecture on case studies in modeling of Tundish steelmaking 1. So, we are going to have the discussion on the case studies of different type of work which are being carried out in the modeling of Tundish steelmaking process. So, in the next lecture also we will talk about the similar type of case studies. So, in this lecture we are going to have the discussion about some of the parametric analysis, and this is the outcome of certain of my research work, and you can even see such kind of work in the literature which has been reported in the international journals or conferences. So, I have tried to analyze and discuss such kind of work which can be thought of being tried by the researchers in the industries or in the academia, and also this kind of work is still going on. So, we will try to have discussions on certain such kind of work. So, we talked about the mixing as well as the inclusion separation processes which are one of the important duty which is performed by the Tundish, but here we are going to have the discussion on those aspects for the different configuration of Tundish. So, there are different kind of Tundish which are reported, different shape of Tundishes, and how they perform, how you do the analysis, how you can have the visualization of the output results. So, that can be seen in those so how that we should see them. So, that we will see in this lecture. So, we have basically taken these 4 different type of Tundishes. Basically, they are the outcome of certain research work which I did for even the ministry, that is DST. So, they are the outputs also, we got similar outputs there. So, we acknowledge the support by the DST also. So, this is suppose we are in that the study was carried out on these 4 different kind of Tundish. So, normally we deal with the two kind of Tundish, that is delta shape and boat shape. So, that this is known as boat shape. So, in normal this rectangular type of cross section, and that is being extended. So, that is your boat shaped Tundish, but then here in the case of delta shape you have on the symmetry line you have the larger cross section, and then it is smaller towards both the side. So, this is your symmetry plane. It means the similar dimension will be coming on the opposite side also. So, you will have a larger Tundish. So, the whole Tundish is about 6 meter, 6000 millimeter, and in this case you have this is your V shaped Tundish. So, here actually you make a V type of shape. So, it will be like this way. So, you will have this is a 45 degree angle. So, that that will be your this is the type of shape. So, that is what you see. This is your that type of shapes. This is V shape, this is inlet. So, this way you will have the extension on both the sides. And another shape which is also being reported in the literature is T shape. So, in the T shape you have in this case you have the slanting type of slope is there. So, your and in this case your up to certain distance you have the larger width, and then it becomes smaller. So, that is a T shape of Tundish, it is known as. So, as you see these are the 4 different type of Tundishes were taken, and it was these are the geometrical parameters. It was seen that normally we keep the volume as constant. So, that volumetric flow rate also is kept constant when the inlet size is same. So, that is what but now we need to know that when you do the analysis, how they perform for the main purpose for which the Tundish is being used. So, we will talk about it. So, also we discussed we will use maybe if possible in this lecture or in the coming lecture, we will see that how we can describe the different cases when we use the flow modifiers. So, when you use the flow modifiers will be A1 to A3, B1 to B3 or C1 to C3, and their placement will be varying. So, A or B or C. So, A is closer to the inlet, B is somewhat distant, and C is quite far near to the outlet. Similarly, there the subscript 1, 2 and 3 will be talking about the different heights we are taking. So, height of that flow modifier, that is dam especially we have taken, so that its effect will be seen on these parameters. So, if you look at so what we did again it was for getting that you need to solve these equations. You treat the flow as turbulent. So, you have to solve the appropriate equations even for turbulence also. If you take the K epsilon turbulence model, you have to solve these two extra equations for K and epsilon. You can take any other turbulence model, and then ultimately you try to solve the concentration equation also for the pulse input analysis for the tracer concentration which you get during the pulse input. And so, first of all when we solve these equations, so in that you are going to have the velocity field, steady state velocity field you are getting inside the Tundish. So, we will try to have the velocity field which you get in the case of Tundishes. So, if you look at the velocity field, so velocity field as is shown on the bottom plane. So, this is your bottom plane, these two are the bottom planes as you see, and then on one of the side plane also the velocity field has been shown, and it is seen that the Tundish from the inlet the liquid steel will be going down, it will be striking here, and then it is moving towards the outlet, and since there is no flow modifier here. So, what you see that initially the velocity is very high, it will be splashing on all the directions. So, it will be going similarly on the opposite side also. On this side it will be going over the wall. So, that is what it is seen, that it is going over the wall, and then it is moving towards the outlet. So, this way your flow will move towards the outlet, you will see the higher velocities and slowly they become lesser because of the the stresses which occur because of the wall and all that. So, slowly the velocity will be lesser, and then ultimately it will come through the outlet. So, these are the velocity field on the bottom plane, and also on the side wall. One of the side wall has been shown for clarity. So, that is shown in the case of the boat shape as well as on the delta shape. So, if you go to the other kind of shape of Tundish, so it is on V shape as you see here. So, you will have, if you look at the line, this is the velocity vector which is showing 0.379, this is 0.379. Similarly, this is 0.757. So, here if you look at this, here the velocity is quite high, and this way it will be going, and this is your T type of Tundish. So, you see the velocity higher, it becomes lower in this range because it is somewhat distance, your inlet is here. So, it will be falling here. So, coming to this side the velocity will be smaller, but then this way it will be, you will have larger velocity on this side and a smaller velocity on that wall side. So, that is being shown in this case, and you see the lower velocities on this side, where higher velocities on this wall. So, these are the so this way you can have an idea about the velocity vector which you draw, and you should draw the velocity vectors on those surfaces from where you can have the clarity. You can draw certain inferences, you can draw certain conclusions by looking at those velocity vectors, which will tell you that where the velocity field is higher, where the velocity is higher, where it is lower. So, which if it is very low, it may be likely to have certain dead zones also. So, this is how the velocity vectors are seen. You can have the velocity vector also on the vertical planes passing through the inlet and outlet, because we have the inlet and outlet plane, that is on a vertical plane. So, for the boat shape it is showing like this. For the delta shape, you can have this inlet and outlet plane, you can have the velocity vector going like that. Similarly, on the plane of on the V shape and T shape, you can have the view of these velocity vectors on those vertical plane where on which the inlet and outlet is situated. So, that way you can have the these velocity vectors also. So, ultimately after having the steady state velocity field, we are solving for the pulse pressure concentration. So, that is given for a small amount of time as a pulse input, and then its concentration will be measured at the outlet, and then it is plotted. So, what is seen that if you look at these you see that you have a higher peak in the case of the boat shape, but it is coming at a later time, maybe not so late. If you see the appearance of the tracer, which is there delayed for most time, that is for the T shape, which is indicated by the blue color, and the V shape, what you see is that you have very high very early appearance in case of V shape. That was seen by, if you refer the velocity vector also, you can see that the velocity is seen quite high, and in that case it reaches the tracer will reach to the Tundish outlet early, that is the indicative of this line. So, that way and it is going like that, and then you will have the its but what you see that they are coming slowly, and the value is coming smaller on this side. You have the red shape by the delta, and you have all these different Tundishes will have the RTD curves. You can have these, and you can then analyze by when you even you look at the its other parameters like mean residence time or ratio of the mean residence time. So, if you find the ratio of the mean residence time, that is actual to theoretical. So, that if you look at you will have the minimum for the V shape. That is what it is clear that the V shape, because it has the its stay in the Tundish is minimum. So, short circuiting is maximum in this case, tracer has come and it has directly gone. So, the liquid is not able to go to every corner, it takes a path because of which short circuiting takes place, and your mixing capability or the way the fluid will go inside, the residence time during which it will be moving inside, that is basically minimum for the V shape, and it is maximum for the T shape. If you look at the T shape, so T shape is blue, so it is coming late, it is coming in the last, its appearance is seen at the outlet, and then it is going, and it has and also you see that it is having minimum values also up to this region. After that, even concentration value becomes less. So, but then it is going quite early, it is going quite late, and then at early time its value also become less, and then it is going. So, that way it tells that the mean resonance time for the T shape is maximum and for the V shape it is minimum, and then delta shape is seen to be better than boat shape, but not better than the T shape as far as the ratio of mean resonance time is concerned. And another thing by which you can have this analysis by looking at the concentration isolines. So, you can draw these concentration isolines with time. So, because the when you solve these tracer concentration equation, that is basically in a transient manner. So, you are with time variation you are plotting these variation in the concentration at the outlet. So, what you see that as the time is progressing, the tracer will advance towards the outlet. So, at different times if you look at this is in the 5 second, if you see the tracer has advanced up to this point, and then in the 10 second, this is for the boat shape, bare boat shape Tundish, and these are the concentration isolines that helps you to understand that how tracer is moving towards the outlet. So, you see that if some tracer has gone, its concentration is maximum at the outlet, at the inlet when the at the initial time, that is 5 second, and then as the time progresses you see that these are going down, the value is going down because now the tracer is moving. So, if you look at 20 second, the tracer is moving more here towards this. So, concentration is more on this, and then it is coming and appearing through the outlet. So, this is how you see that first appearance of the tracer will be somewhere close to 20 second or so in the case of boat shape, and then it moves, and further finally if you look at the 40 second, your maximum concentration is here, and then it is moving on the towards the outlet. So, it will be moving and going directly, this stream will be going towards the outlet. So, as the time is progressing, the concentration value also will be decreasing, and your tracer concentration, if you look at, this will be quite small here, and then it is increasing on this side. So, then it has it is coming now through the outlet. So, this is how you now this is basically required to study the movement of tracer, how it moves. So, it will basically be going through the as per the velocity field which is existing inside the Tundish itself. So, as you see that it is going by following the wall and also side wall as well as the bottom wall. So, that way it is moving and going towards the outlet. Similar thing can be observed for other kind of Tundishes, like this is for the delta shape. So, here also again the same way it is moving, and then it is coming out through the outlet. If you look at the this is the V shape Tundish. So, what you see now in this case you see that quite early it has come, basically in 5 second, in 10 second itself it has come on the outlet. So, that is why you see that in this case basically it quickly comes. So, that is why there is short circuiting phenomena that can be observed here, and the mixing the mean residence time is basically seems to be is seeming to be quite small as compared to other kind of Tundishes. And if you look at this T shaped Tundish, now in this case you can have the idea that it is going little late. It is going from because it will be going towards this wall, and then it is moving, and then ultimately after some time it will be coming towards the outlet. So, so that way here the appearance is quite delayed, and that is how you can have certain kind of inferences by which you can conclude that why it behaves better. So, these are the ways by which you can do these modeling. This is in the case of T-shaped Tundish. You can also do the inclusion studies in the different kind of different shape of Tundishes. Inclusion particle trajectory can be calculated and that can be seen. So, what has been seen was that the inclusion removal was minimum in the case of T shape, it was maximum in the case of V shape. So, these are the studies which was there, but that can be that will be depending upon many parameters, and that was one of the result which we got. Now, another thing which was done was the geometrical parameters of the Tundish on mixing and inclusion separation was also studied, and that has its bearing. Because many a times we have shallow Tundishes, we have larger Tundishes or smaller Tundishes, we have less height or less width or so. So, what will be its effect? So, that also can be done, and in that basically there are 5 cases, one being standard. So, you have other 4 cases, like in one case you are decreasing the height and you have increased the height, similarly you have decreased the width and you have increased the width, and one is standard, that is H and W. So, once you do that, then you can have the idea that what are the effects of the variation of these geometrical parameters. So, that can be seen, and you can have the analysis of the velocity vectors. If you look at when you decrease the height or increase the height, or you can have the decreased width cases or increased width cases. So, you can have a primary feel that how the velocity vectors are changing, because the you can see that if since being the width being smaller, it becomes more dense here, height becomes smaller, it becomes more dense here as compared to the standard or the increased dimensions. So, you can also analyze these velocity vectors at the at the vertical planes for the different standard case, and then you have the other cases of smaller height or smaller width or larger height or larger width. So, that way you can have these drawn and see the velocity vectors. That is at the this is at the side walls also. So, that is shown here. Then this is for the this is for the that was for boat shape, and this is for delta shape. So, how delta shape it is changing. Then you have the boat the V shape. So, V shape also you have the different dimensions, and then you have the different type of flow vectors, and then this is now finally the T shape. So, in the T shape also we have changed these sizes, and you can have the feel of these velocity vectors at the different positions. Now, based on that basically then you do the the studies of the RTD, and with the help of RTD you can have the calculation of the mixing parameters, and this is again on the vertical plane, that is for the T-shaped Tundish. And then you draw these RTD, and based on the RTD you can have the analysis, and you can see that how they are how they these different change in the geometrical parameters, they will be affecting these RTDs. So, what you see, if you look at the boat shaped Tundish. So, in the boat shaped Tundish it is starting here, delta shape will be starting here. In the V shape we have already seen that it will be starting quite early, and T shape will be starting the most late way. Now, what you see that this red portion is the change in height, and so it will be smaller one, and smaller width will be blue. So, if you look at the boat shape, what you see is that the peak is smaller in the case when the height is smaller. Now, that is also seen in the case of delta shape also, where you have the peak is smaller when you have a height is smaller. But that is not seen in the case of V and T shape, because in these cases the peak is not small, although it is in the case of T shape it is not the highest, but in the case of V shape it is highest. So, so what you see that with the smaller height, possibly we should get the maximum that parameter. If you look at the boat shape. So, with the height smaller height, if you look at you see that it has maximum ratio of MRT because of this smaller peak. So, that is what is seen, that you have, that is seen because of this peak. Now, again if you look at the width. So, if you see the smaller width case, so this is again a smaller peak. So, it will be better MRT that is being observed, but if you look at these V shape, in that case these smaller dimensions are not showing improved results, and that can be seen by for the V shape. So, in these cases your ratio of MRT is being smaller. So, this is good for because in the case of V shape we have already seen that is anyway the MRT is smaller, and when you are making it smaller, the more quickly the pressure will go through the outlet. So, your short circuiting phenomena is even more aggravated. So, that is why your MRT or the mixing parameter, basically the ratio of MRT. So, that is decreased for the V shaped Tundish, and for the boat shape it is or delta shape, you see that it is okay, it is somewhat better as compared to the larger height cases. And standard we have already analyzed, and if you increase these height, so this is greener. So, increasing height will be worsening the ratio. So, in the case of delta and boat, that is what it is seen from here. So, increasing the height, what you see is that normally you do not have improvement in the case of boat. In the case of delta, you can see there is marginal improvement. So, that is one. Now, in case of V shape, as you see, the best performance is by this light blue or that color. So, this is 1.2 width. So, that is showing even better result, and that may be seen for the 1.2 width. You see that this is quite high. 1.2 height also is showing better result. So, that is seen from those by looking at those curves. If you go for the T shape, you see the 0.8 width is showing the minimum one, and that is why 0.8 height. This is 0.8 height. So, that is showing that maximum one. So, that way what you see that by looking at these graphs, you can have one feel that how these these RTDs can be interpreted to have the effect on these parameters like main resistance time or even the mixing parameters. We also did the inclusion behavior, and what was seen was that the boat shape, delta shape, V shape and T shape. So, what was seen that the maximum inclusion removal was with the boat shape, that is with this rectangular shaped line, and no, this is not that. This is the delta shape is showing the maximum with the height, and for this if you look at the V shape. So, this is triangle 1 and this is your V shape. So, it is coming down and then it is further going. So, that way it is better for the 1.2 height. So, by looking at this also you can have one feeling that how these Tundishes are going to perform when the geometrical parameters are going to change. So, this way there are different kind of you can have the analysis of these results by looking at the papers in the literature, and you can have a feel about and confidence also in interpreting these results, and justifying a particular shape or size of any Tundish for the industrial use if you are working in the industries, or you can have a model, physical model setup also. There also you can have these studies and verify them. So, that is about this, and we will have a few more case studies in our coming lectures. Thank you very much.